We want to create machines or computing devices think as we do, see as we do, and reason as we do. Are we there yet? Hopefully by the end of this presentation you will get the answer to the question. But what is empowering this system is called machine learning. And machine learning is nothing but the art of, of making machines to think, see, and hear on their own without being explicitly programmed. Because traditionally what we do in the computing world is define set of rules for anything.
Excuse me, sir.
Usually because most of, can you all hear me?
Excuse me, sir. Yeah, I just
Okay.
observed the slide is not moving.
On your end or on my end?
Your it has
On my
changed
end
now.
is moving.
It
Oh, okay.
it it wasn't just changing before. This is the second slide I'm seeing now. Just an
Uh,
observation.
oh, thank you. So it might be lagging. I don't know why.
Okay. Thank you.
So, so as I was saying, we have been traditionally programming systems based on set of rules. You know our if-else statements. If this, do this. Understand? But that is not the way we want we humans act. We are not programmed explicitly. We learn using a set of rules on our own, and that is called experience. And the world of computer science is called data. But behind the scene, machine learning has been there. It's nothing but the classical machine learning algorithm or the statistical algorithm that we know of. For those of you who have background in mathematics, I'm talking about mathematical modeling, because you can model systems using differential calculus, and people have been doing that for centuries. But the idea of using traditional or classical machine learning or statistical algorithm is not powerful enough to empower the systems that we are seeing today. We need another branch of machine learning called deep learning. And deep learning is what is empowering all the systems that you are seeing, be it the Google Siri, Google or Google Assistant rather, Siri, and what have you, as well as the driverless cars that we see today. The idea is this: we human beings will have a connection, have an organ in our body that allows us to reason and think. And that organ is called our brain, and is the most powerful organ in any individual when it comes to the cognitive side of things. And for us to create machines that can act and think like we humans, we need to provide, we need to understand how our brain functions. And because of that, the idea of deep learning comes into being. And deep learning is nothing but a subset of machine learning, or you can say a branch of it, that allows those algorithms to learn some certain features in any kind of data, be it textual data, be it a visual data. But what is behind the deep learning itself? What is behind it is nothing but neural networks. And these neural networks, they got we got the names from the neural connections in our. Let me take my time to explain what's happening here. Even though I don't have a pointer, so I don't know. So those three dots that you are seeing, or the three heads that you are seeing at the beginning, they are called the input layer, and then the two that you are seeing in the middle, they are called the middle. It's called the middle layer, but each one of them is called a neuron, and inside each of them, this is what is happening. This is a mathematical operation that is happening. It might be a little bit confusing, but that is what's happening. So why are these neural networks so popular now? They are so popular because they allow the machine learning algorithm that we are building today to learn and extract some certain features that are really valuable in the understanding of what we want to see or what we want to hear using the AI as a system. Because in the class, for you to understand what's happening here, you need to understand the basic machine learning or statistical algorithm, logistic regression, linear regression, random forest, and what have you. There you need to do what is called feature engineering. If you are given the data, you have to do some certain feature engineering. But when you are dealing with neural networks, you don't need to do that. Maybe you have to normalize that, you may have to do that, but anything other than that, the machine will understand on its own what are the relevant features that it needs to extract for it to carry out the machine learning task or the predictive task, be it whether it's classification or just regression problem that is trying to predict a certain number. And using these neural networks is empowering us today to develop systems that can be able to see objects, whether in images or in videos. And in this and on these slides, what you are seeing there is a object detection algorithm that is being run. I think it's a video, so it's able to detect a pedestrian, some other buildings, and then cars and what have you in the picture. And that is in the domain of what is called computer vision. But in natural language processing as well, that deals with the way we talk with each other, we communicate using audio, voices, text as well. Machine learning has achieved a lot of success. I believe each and every one of you is having a smartphone, right? And in it there is a basic application. If you are using an Android, almost everybody has one, I believe. There is what is called a Google Assistant, and it can allow, you can say, hey Google, please, what is the weather in Abuja, or what is the weather in Lagos, or anywhere, and it will tell you, okay, this is the weather now. And you can even ask other information, all using your voice, which was considered unimaginable or unthinkable at this particular time, maybe like 30 years or 40 years ago. But today, because of the power of artificial intelligence in most of these devices, we are able to communicate in a far better way than we've ever done before. So why is AI so important? AI is so important that almost every government is talking about. In fact, because what we have already seen, we've already seen its power in analytical and strategic thinking, as well as in speech transcription and translation, and equally in medical diagnosis, and also in medical robotics, because we've seen the power of this, especially in the field of health. of COVID, we've seen how this can also interact with the patients. But despite all these successes that we've seen so far in AI, there are some huge challenges that are bedeviling the field. And some of these challenges are data quality. Access to qualitative data, not data, but to a qualitative data is a huge challenge, especially in some key industries like in healthcare.
Excuse me, just to be sure, your slide is not moving.
But the one that I'm having here on my please, I think I would suggest the person that is in. I think I shared this slide with you guys. Steven. Hello, Steven. Can you hear me?
Yes, I can hear you.
Yeah. Can you please control the slides? I think that is the reason why I added you, because there sometimes you do experience some lagging. So maybe you should be in charge of the slides now.
Okay, sorry, I don't really have access to control the slide. I'm trying it from my own end, but it's not
Are you
working.
sure?
Are you using PC?
No,
No, I'm
I'm
not
not.
using my PC.
No, I mean, Miss just President.
No, sir.
Okay, the media will control that now.
All right, that's better.
Yeah, and I just observed that I had like the slides. I'm way ahead of what you guys were seeing. Like, I'm sorry. So okay, dialogue system.
The dialogue with the
I think
machine. Is that what?
I just finished slide 11. Are you guys on 11?
Okay, this is why is
Yeah,
AI.
this is slide 11.
Okay, you can go on, sir.
And then the next one is on the AI challenges, and that's slide 12. If I'm not mistaken. Yeah. So I was explaining some of the challenges, and these are the key challenges that is confronting the development as well as the advancement of artificial intelligence, especially in the developing countries like ours, Nigeria. Access to quality data, to a qualitative data, is still a challenge, especially in agriculture and healthcare. But I think the challenge in healthcare is even more pressing because of a lot of regulations in place to ensure that data on a patient's data are not revealed to the public. So you have to like kind of like anonymize the data so that it won't belong to anybody. So that is a challenge. And then also when it comes to annotating the data, because you need to label the data. So labeling the data, if you are, let's take an example of, let's say you want to detect a cancer on a CT scan. Let's say it could be a brain cancer, it could be a lung cancer. So you need the radiologist to do the labeling for you, to annotate the data that, oh, you see on this CT scan there is a cancer, or there is a nodule that can lead to cancer. So that is part of the challenge. And there is something in computer science that we are all familiar with. It's garbage in and garbage out. Same thing with the machine learning algorithm. The data you feed into the machine determines the outcome. largely determines the output you are going to get. So access to quality data is a challenge, a huge challenge, especially in Africa or in the developing world. And then the second biggest challenge is the computing power as well. So some of these algorithms that you are seeing that are enabling us to see things, to diagnose cancer, to detect objects on the way, that is in driverless cars, they were trained for months on some of the most powerful computing devices you can ever imagine, using tensor processing units, which is like an advanced version of the graphical processing unit that we know of GPUs, right? For months at either Google, Facebook, or OpenAI. So you need the computing hardware, and this is a huge challenge, especially in the developing world. And then another one is this issue of the machine learning algorithm being a black box. So if you are coming from the mathematical background, because you are used to seeing models and then you model phenomenon, they are just basic kind of like differential calculus, you might not consider machine learning algorithms as black boxes. But if you are coming from any other field, you say it's a black box. Because mostly what people see is the data that is being fed into the algorithm. What is happening inside the algorithm, the processes, nobody understand, or a lot of people don't understand what's happening, and that's why a lot of people tend to call it that is a black box. So we need what is called explainable AI, even though there are a lot of frameworks that are being developed to explain what is happening behind the scene, and still people are complaining about this algorithm being black boxes. And then another challenge is the issue of generalization. The concept of generalization can be divided into two. Generalization in the sense that you train the machine learning algorithm to see statistic information on a particular task, let's say exam scores of students. And then you tend to take that same model to another department or national university. That algorithm might not perform as well as it did before.
Abeg.
So that is one way of seeing generalization. And then another way of seeing generalization is when you train your machine learning algorithm on the training data sets, and then you maybe let's say you have like 90% accuracy, then you take it and then try it with the data that you can now see while performing training. The performance of that result might be lower than yours, might be like 60%. In the field of healthcare, agriculture, this machine learning algorithm will not be acceptable because you are dealing with raw data at an analytical stage. So these are some of the most pressing challenges
I did
the
class,
development
that's
field
why.
are facing. So are you guys on the next slide? Hello. So can you go to the next slides? Can you go to the next slides? Hello.
Marcos, now the media, please, what's the next slide?
Yeah.
Please, the media, if you're there, could you please go to the next slide? That should be slide 13. Thank you. Yeah, slide 13 now, so you can continue.
Yeah. So thank you. So what is the biggest concern when it comes to AI? I know you must have come across something in the news that AI is here to take over our jobs. AI is here to kill us. These are the kind of issues that are being raised by people that are even in charge of this algorithm or in charge of developing this algorithm. That if there is no any ethical or a regulatory framework, there are some serious concerns that AI systems or AI powered systems Hello? Hello? Can you hear me?
Yeah, we can hear you, sir.
Yes, we can hear you.
So as I was saying, so the biggest concern has to do with ethics. Like who is going to be in charge of these AI systems? Are we going to leave these AI systems to say companies like Google and Facebook? Or are we going to give the responsibility to our governments? And the question is, we need to trust our governments enough. So there are a lot of frameworks that are being developed on how these AI systems should be regulated. The European Union has produced one in the year 2020. It's the only one that is available currently. US and other countries are developing theirs, as well as Nigeria is developing its own. So because without somebody, quote unquote, a guiding angel that is going to oversee what these algorithms are doing, there are some negative consequences that could emanate as a result of this system being used to decide who gets employed or otherwise, to decide who gets admission into our institutions or otherwise, to decide who gets a welfare package or otherwise, and a lot of other concerns. And that is the biggest issue. So to end my talk, I would like to look at this quotation from Andrew Ng, who is one of the most popular and one of the most relevant AI researchers, especially in this 21st century. And he says, artificial intelligence is the new electricity. So the question is it? Thank you very much. So any question?
We sincerely appreciate you, sir, for so much of this to actually explain to us more what AI and thank you for your time. So very appreciate. And please, if you have a question, probably on the side of the email, so you can write things down just in case you have questions, and so that you can actually ask your questions just in case you forget. If you have a question, kindly unmute your device and introduce yourself and study center in your name, and please do ask your question. For those of us, please be reminded that the link for the participation or attendance is actually being posted on the comment box. So if you click on it to actually fill in the attendance. We all said issues is between the end of this. And I think some people have been asking about the slides, but for some comments, the speaker just said